Hi everyone, welcome back to the series. And in this video, we will be seeing a practical approach towards big O notation. We are going to dive into the examples of big O notation, and we will be writing JavaScript code to illustrate each of the common big O notations. And I will explain it in simple terms as well. So before that, let's see what we learned in the previous video. So we saw what big O notation actually is. So we can say it as a way to describe how long it takes for a computer program to run based on the amount of data it has to process. It is like a way to predict if the program will be running fast or slow as you give it more data. Understanding big O helps programmers choose the best algorithm for their task and make sure their software runs efficiently even as it deals with larger and larger size of information. So now let's start with some practical examples of big O notations. First, we have O of n, linear time complexity. This means that the time it takes to execute our code grows linearly with the input size. It's like reading a book page by page. The bigger the book, the longer it takes. So let us consider our code example here. So in this snippet, we have one for loop, and the number of times this for loop is going to iterate depends on the position of the target value that we have in the array. So for example, let us take the array to be 1, 2, 3, 4, and 5, and let us consider the target value to be 1. So this would be the best case scenario for finding out the value from the list. So in the zeroth position, when the for loop executes first time, it is going to get the value of the target and it will return the function. So the execution time of this is going to be the minimum, and it is known as the best case scenario or omega. Let us consider the target to be 3. So in this case, what will happen is the for loop will iterate for 3 times in order to find the value. And this is considered as the average case scenario or theta. And third, we have the big O, which is the Omicron case. So this is the worst case, and always big O is considered as the worst case scenario of a function. So here we have the value 5. So 5 appears at the last of this array. So it will iterate the for loop for 5 times, and then we will be having the function execution completed. So by this, we could see the worst case of this function would be n times, which represents the position of the target. Up next, we have O of 1, which represents constant time complexity. It means that regardless of how much data we have, the time it takes to execute our code is going to remain the same. Think of it as an instant operation. So let's see our example. So here we have a function, whatever be the number of time we execute it or the value that we are going to pass it, it is always going to run at the same constant time. And next we have O of log n, which represents logarithmic time complexity. It's like dividing our data in half at each step, making it efficient for larger data set. Imagine it as finding a word in a sorted dictionary. So we can also consider a binary search. Let's step into our coding example now. So in this example, we could see our array is being split into half by every iteration that happens. So every time the loop executes, the size of the data set is going to be split by half and it reduces. Hence, we get the log of n time complexity. And finally, we have O of n square, which represents quadratic time complexity. Here, the execution time grows exponential with the input size. It's like comparing every person in a room with every other person, which is highly inefficient. So for this example, let us consider a nested for loop. So in this nested for loop, we are looping through an array twice, once outside and inside the array. That is, for every element, we are again comparing each and every element in the array. And the worst case would be when we don't have the exact match, or when we don't have two values in the array as same. So before we close our video, let's understand this essential concept. So let's say we have a for loop and below that we have a nested for loop. Now in this scenario, the big O notation for this snippet would be n plus n square. So in this case, we can neglect the n in front of the plus sign. This is because whatever we measure in terms of big O is going to be the proportionality of the performance of the algorithm. So here we always consider the worst case scenario for the big O. So having n in front of the plus operator can be negligible, since n will be a smaller number when compared to n square. And so this is known as drop non-dominance. I hope these examples have helped you understand how different algorithms behave as different scales. This knowledge is invaluable for choosing the right approach in your programming task. In the next part of the course, we will explore more advanced topics in data structure and algorithm. So stay tuned. Don't forget to hit the like button, share and this video with your fellow learners, and subscribe for more tech related contents.